Hi, welcome to the intro to Go. This will be a very ad hoc kind of Codelab because we decided yesterday to do this today, but I think we're going to be okay. I'm going to talk for just maybe 5 minutes about Go so you know some of the basics, and then we'll try to do something more hands-on. Codelab, Fortunately for Go, there's an what they call an online playground. It's a web page where you can enter Go code and run it right there, so you don't have to install anything for today. So, interrupt me anytime. This is supposed to be an interactive thing. If you have questions or anything. So, you can say a lot, obviously, about any programming language, but for me, like, the essentials are, first of all, I found it really fun to work in Go. It's nice and easy, and I was really productive really soon after picking it up. These are always good things. And if we look about language features, I just want to highlight 3, which are kind of unique about Go. The way it handles interfaces, the way it handles composition of programs with structs, and the built-in concurrency features. Maybe one sentence in general, so Go is a pretty low-level language. It was designed to be kind of the next C, of course with a lot of ideas from other languages. And it's a garbage collected language. You don't have the memory management for C anymore, but it's still kind of low level, and it's something you have to keep in mind. So interfaces. Go has interfaces like you maybe know them from Java, but but with one cool twist. You don't say implements, blah blah implements interface. The Go compiler figures it out automatically, and this is really a big thing in practice. So let's say we want to read from a CSV file, okay? So package CSV has a method new reader. You give it an io.reader, and it returns a CSV reader that reads lines from a CSV file. Now, io.reader is a simple interface with just one method. You give it a slice of bytes, and it reads into that until it's full, or until there is no more data. That's all. So far, so good. Now we want to read from a file. We look in package OS, operating system. There's open, very simply the file name, and you get back a file object. Now we have a problem. We have a file object, but the CSV package runs an io.reader. Now in Java, you would have to instantiate some kind of file readers, something that wraps the file and then implements a reader. But in Go, you can skip all that. File has a method read. And if you compare, the signature of this method is exactly the same than here. And in Go, that means that the file object implements io.reader. Because it has the exact same method with the same signature, and you as a programmer, you never have to say file implements io.reader. So what I can do is I can just open a file. I get a file object, and I pass this file object to new reader. Are you kind of with me? You don't say implements blah blah. And this is really quite amazing. First of all, it saves you from a lot of boilerplate code, and second, it really decouples your different packages, your different libraries. Because in Java, if you say implements so and so, you have to import that package. And if you import a package, you have a dependency. In Go, package OS does not import I/O. This is not necessary. You can just implement the method with the raw signature, and that's it. And this allows a lot of decoupling, a lot of flexibility. And it makes Go feel a bit like a dynamically typed language, Python or Ruby, even though it's statically typed. So this is quite cool. And we can try it out later.
So then how does it handle namespace collisions? If you have a different function which has the same pattern, how does it know? When you sort of give it, and you say this is like the file is going to use a reader I/O thing, and then
well, the file object can only have one method with a signature, and that means it implements IO.reader with this method. So there's not really a potential for collisions. I mean, you have the packages for namespacing, IO, CSV, OS, and they can have, in any package you can have different implementations of the same thing. And if there's ambiguity, you can, we will see this later, how you import a package in your code. But let's say if you say import CSV, then by default this is called CSV, but if you have a collision, you can give it a different name, CSV1, CSV2.
The second interesting thing I wanted to highlight is the way Go does composition of objects. If you are Java programmers, who works in Java most of the time, you have probably heard that since a couple of years people say composition over inheritance. You know, you shouldn't overuse inheritance. It's better to compose objects together. This makes sense, but the problem is in Java it's really annoying to do. Let's say I have food type which has a name, and then I have a bar, and I want this bar to have a food. Okay. In Java I could either say bar implements food, and then bar has a name. But this is not very flexible, and you have these big type hierarchies, and it's hard to test and so on. So any modern Java book will recommend that instead you give bar a field of type foo. Okay, that works. But then what if you want the name of a bar? You have to say bar.foo.name. And if you want a method, you have to implement get name, and get name says return this.foo.name, and it's just a lot of code that accomplishes nothing really. And what's even worse is you expose the way that this object is structured. And in Go, you do it differently. Go has built-in support for embedding types or composing types. I just say, like here, but I just give the type here. There's no field, there's no variable. What this means is that each bar has a foo in it. And then I can say bar.name. This is the Go syntax for making the struct. I just pass in the string, and it's set to the name field, and then I can just say bar.name. And anyone using that code does not see or does not know that bar has a foo in it. It's all behind the scenes. I can just use that name field, which belongs to foo, because it's inside bar. Yeah.
If you have a composition with two objects which have the same field names,
Yeah, it's not allowed. It's not allowed. If you have that, you need to be explicit. You can always be explicit, like you would. I mean, you can always do this,
I see.
and then say foo.name if you want. Yeah. This is also one of these features that, when I first saw it, I thought, okay, it's nice, but whatever. But actually, it's amazing, because let's say at some point foo is obsolete. You don't want this foo anymore, but bars should still have a name. Okay. You totally change the implementation of bar, but this client code doesn't change.
because the client code never saw foo. It never saw anything about foo. That's pretty nice. And then, so you don't get bored, we come to the last thing I wanted to quickly show, the concurrency features. We need to take a little time to go through that code because there's a lot of stuff going on. But, so Go has built-in support for running code concurrently, which is not really the same as parallel. If you have only one core in your computer, it cannot run in parallel, but it's still a concurrent design. You launch some code, and you continue asynchronously, and then you read the result from the asynchronously running code. And to let these concurrent pieces of code communicate, Go has a special type built in, which is called a channel. The first line we make a channel of type int, so a channel where you can pass ints between pieces of code that run at the same time, at least conceptually at the same time. And then here, ignore that word Go here for a second. This is a simple function that counts from 0 to 9, and it sends the number 0 to 9 to that channel. It's an arrow operator. So you can read this as I goes into the channel. So you send this down the channel. When you're done, you close the channel, saying no more communication. Now, when you can have any piece of code, or have a little syntax error that needs to be two parents to actually execute. But if you can put Go in front of any statement in Go, and then this means this will run. It will launch this piece of code and continue right away here asynchronously. So this will, if you have more than one core, this will run in parallel. And if you have just one core, it won't, of course, but conceptually it still will. So you launch this and say you go off, and then you continue right away. If you don't know Node.js, it's the same kind of asynchronous model. And now here, the range is a built-in to read from that channel. Now here we read those ints as they come in and print them. Just to give that a little, yeah.
So you are saying that you can run in parallel if you have two cores, but if you want to, they are going to write 1, 2, 3, 4, 5, 6 until 10, or will be first the 3, then the 5, because that is in parallel?
Yeah, in this code it will write it in order. It will only run, if you have several cores, in this case it will run 2 threads in parallel. This is one, but this code still runs sequentially, because I have only one Go statement. So this launches one separate Go routine, and the main method here is the other 2 threads. And Go has a built-in runtime that multiplexes these Go routines onto actual operating system threads, so you don't have to worry about it. These Go routines are extremely cheap. On a normal machine, you can have over 1 million of them easily. And if you have, let's say, 8 cores, then Go will run maybe 6 threads or 8 threads or 10 threads or something like that, and multiplex your 1 million Go routines onto the available threads. And if you imagine that, this is a stupid example, but if you imagine that this operation here is expensive or is long-running file I/O, you just launch this, and as soon as it's ready, you can read from the channel.
So questions on the code here. So the code as you've written there, apart from the 2 brackets that you mentioned, is that valid?
Sorry? Yeah.
Is that valid code?
Yeah.
So you can have inline anonymous functions.
Yes, and it has full closures too.
Yeah.
I could use it. No, I actually do. I use this channel variable from above without passing it in. It's a closure.
Okay.
Like in JavaScript.
So
Cool. And second question, if you have two different Go routines which are manipulating the same mutable, let's say, global object of something you shouldn't do, what happens if you do it? Does it have any...
You have to synchronize somehow. If you
Okay.
don't, it's undefined.
Does it have primitives? Sorry to mean, it might be you should not do this.
So Go has the typical built-in synchronization stuff like mutexes and so on. Although in Go you tend to use them not very much. What you tend to do instead is you pass the data you want to manipulate between channels or through channels between the Go routines and use that for synchronization. It's more expressive and more flexible. There's a slogan that the Go developers are saying. How does it go? Share memory by communicating.
Okay.
Yeah, that's kind of the design idea. And you can block. I mean, these channels. There are actually two variants. It maybe goes a little too far, but there's a blocking and a non-blocking variant. This is the blocking one.
What makes it blocking?
Then I didn't give it a buffer.
Okay.
If I do this, I give it a buffer of 10. Then this code can write into the channel, and even if no one reads, it just can keep writing into the channel until the buffer of 10 is full. But with the code I had before, one second, code I had before, it will write the 0, and unless someone reads the 0, it will block there.
Okay, so it's an implicit buffer of 1.
Yeah.
So, on the first example you show without buffer, it wouldn't be able to run on one core.
Which example? The first one?
No, because if you, in this case, it will do one execution of the Go func, which will write value 0 to the channel, and then that Go routine will block, and then the for none range one will have setting the channel code so it can read using range, so it will run, so it will swap, it'll interleave between the two.
It's able to do that.
Yeah, it can always, I mean, no matter what you do in a program, it can always run on one core. The Go runtime is a bit like an operating system scheduler. It will run the different Go routines after one another, and it knows which one to run first, so it can proceed. You know,
Okay.
it will always work. It might not be very fast if you know, but it will always work.
So it means that it's doing like something like soft threads.
Yeah,
so you don't have it.
Yeah, the Go routines are like soft threads, exactly. And they're multiplexed onto operating system threads, and if you have just one operating system thread, it still works.
So more questions?
Yeah, sure.
The two words make and chan,
Yeah.
are these special to Go?
Yeah.
Okay, so make is...
Chan is a type, like int
Okay.
or something.
Okay, so chan int is that a composite? That's a channel of integers. That's
Channel of
a
integers.
composite type. It's a single type, which is a channel of integers.
Yeah, it's a
Okay.
typed channel, basically. It's like you would say array of int.
Yeah.
This is a channel of int.
Okay.
And make is a built-in function to construct some of the built-ins, like channels.
Okay.
Yeah. So just for a little quick overview. Now, I will put these slides somewhere later, and there I have made the last slide of resources. But now I'd say, I mean, this is supposed to be a Codelab after all. Maybe we try out a little bit of Go if you have your laptops. There's a URL called tour.golang.org.
That's what it is.
give you a minute to set stuff up. Can you read the URL?
Yes.
This is an interactive thing. You can mess around here and click run, and there's a server somewhere that will read your Go, compile, execute, and send you back the result. If I click run, not surprisingly, we see the output. People with laptops, are you kind of ready to go? To go? There's no end of jokes you can do with it. Anyway. By the way, if you ever want to look for stuff on the web about Go, it's not really a word you can Google, right? But there is a convention that the Go community does. You Google for Golang in one word. And this always works. You know, like read JSON Golang. There's the JSON package. So this will work. Anyway. So this is the minimal Go program. You have a package statement at the top every time, and main is the one that has the main method, which is just the main method with our arguments. You can import other packages. In this case, we import format, and we print string. Go strings are fully Unicode enabled, built into the language, which is pretty convenient if you work with non-ASCII. So this is where it starts. It's a bit of blah blah. It's almost the same thing, except we import two packages, and then we can use this parents thing to group it. Although I don't want to go through all of the exact syntax today, that's something you better look up for yourself. It's just supposed to give you a flavor of what Go is all about. Go has one funny thing that when I first heard about it, I thought this is weird, but it actually works. You know how in Java you have private and public and protected, these keywords to determine visibility. In Go, a name is exported if it begins with a capital letter. And that's the only visibility rule they have. So foo is exported, and lowercase foo is not visible outside the package. It's kind of, you think, what? This is really obscure, but actually, I found it super easy because you look at any piece of code and you need one glance and you see immediately which names are exported, which are private.
So main isn't exported then?
No, it's not exported. It's in the package, and it's in the main package, where the execution starts, so it doesn't need to be exported. You see the format print line, so capital P. If it was spelled like this, it wouldn't be visible outside the FMT package. It's a funny little design decision, but it's actually quite nice and saves a lot of syntax. The only thing is that a while ago a Chinese user complained on the menus. He wanted to write his code in Chinese, and there is no concept of upper lowercase. So this was a bit like, oh, okay. But anyway. Yeah, here they actually built in the error. It says line 9 cannot refer to unexported name. This is because this is lowercase, that's uppercase here. There we go.
functions are pretty straightforward. Looks a bit like C, JavaScript, all these languages. The keyword is func. Sorry, and in Go you write the type after the variable name, which, yeah, at the beginning it looks weird, but it reads quite nicely. X is an int, or if you have several of the same type, you just write at the end, you say func add takes X and Y, which are ints. So if you read it like that, it's quite natural. Easy. Very useful in practice. The function can return any number of results. Swap is a function where you give 2 strings and it returns 2 strings.
Does Go make a distinction between simple values and tuples of one element? Does that make sense?
Yeah, I know what you mean,
Yeah.
but it's the syntax is made so that this is unambiguous in practice. This is,
Okay.
I mean, this looks like a tuple, but there is no tuple type in the language. If
Okay.
you look at how it looks for the caller, it's simply 2 variables.
Okay.
It's not a tuple, one tuple with 2 values. It's just 2 variables,
Okay.
2 values.
Okay. So it doesn't have tuple.
Yeah.
Is there a way to do that struct function a bit more generic?
That is a question that is often asked. The answer is yes, but so Go does not really have generics. It has a type that is like object in Java. Like everything is it's called, because it's an interface with no methods. So everything, I mean, it's an interface with no required methods. So everything implements that. And in this case, it would work. You know, we just have to return this. However, of course, then if you in my method, X and Y are just of type interface, and I don't know anything about it.
Okay.
Go does not have something like Java generics where you can say X and Y must be numbers or must implement address or something. Does not have it. This is probably the most requested feature on the mailing list. We want generics. And sometimes it is actually, I mean, it's probably the only thing in Go that annoys me sometimes. But the authors wanted to keep the language sufficiently low level that at any time you read a few lines of code and you immediately can visualize what happens in the computer's memory. They want it to be more of a systems level language, and with generics you kind of lose that a little bit. And so, usually it's not so much of a problem because the Go interfaces are so lightweight, easy to define, and you don't need to write implements, blah blah. So if you need something generic, you usually write a quick interface with 1 or 2 methods, and then you pass in an interface type. But sometimes it's, yeah. Most annoying is with numbers actually, because Go wants to give you full control of memory layout, so you have int 8, int 16, int 32, int 64. And if you write a function that, like add, you can write add xy int 8, and then this method can only add int 8. If you want an add method for int 16, you have to write add int 16, add int 32. This is the only annoying part.
How does Go do collections then? Does all collection types, arrays, hashes, whatever, they're all explicitly typed?
Well, yeah, it has arrays, and I mean it has actual fixed size arrays and variable size arrays and maps, hash maps built into the language. And when you instantiate one with this make keyword that we saw before, then you say make map from string to int, for example, and then it's a map from string to int, and you cannot put anything else in it.
Can you create your own types at the same level as arrays and hashes? Like, could I create a binary tree type and have it treated as first class type?
not on the same level like the built-ins, but of course you can always write type tree, interface, and then you say left. Sorry. Stuff like that.
Okay,
And then of course you can pass around your tree.
I see. And then you declare a new type that implements that interface, and you can use your generic tree code on that.
Yeah.
Very neat.
Exactly. Or if you think the interface is overkill, then just make it directly a struct.
Yeah.
Yeah. And for example, there's one interesting example from the standard library. For example, how do you sort? There's like any standard library, there's a sort method, but without generics, you would normally have to implement the sort method for every little. You have to implement the sort method for int 8, the sort method for int 16, and so on. But they do it differently. They define an interface with 3 methods. Less, the lesser between 2 ints, or is x less than y, and swap. How do you swap to? And how long, and length, how long is your data structure? And the standard library's sort method takes anything that implements these methods, and it can sort it. And this is defined in the interface. I don't remember how it's called, probably sortable or something like that. So this piece of code here is somewhere in the standard library. And to make it a bit more convenient to use, they pre-implemented it for the most common stuff, int float string. And if you want to store anything else, you implement your three methods, and you can store. That is usually how you kind of what you do instead of generics. You define the functionality your type needs as an interface. Everything that implements these methods is one of those automatically, and then you can. Right. Blah blah blah. It's not terribly interesting. Maybe quickly about variable declaration. It has the kind of more C-like explicit variable x is an int and it equals 1. But usually the compiler can infer the type, and there is the colon equals to do everything at once. Just say C is true, Java is string no, and then the compiler knows, okay, this is a bool, this is a string. So usually you don't have to do this var blah blah, in Java. Map string int equals new hash map string integer. It will figure it out. Oh, another interesting thing, another interesting example maybe to highlight this this way interfaces are used in Go. You see that the standard library has this built-in format.println, and you can give it values of any type. Some of these are int, some of these are bool, some are strings. How does this work if we don't have generics? The way it works is the standard library, or maybe the FMT package, I guess, defines an interface called stringer. It has a single method like this. This method is implemented on the built-ins already, and you can implement it on any of your own types. It's like a Java toString, and this method here will simply check for each of those does this type implement the interface streamer? And if yes, it will print the result of this method, and if not, it will just print the pointer like in Java. Alright. Not so interesting. We've already seen the looping. Go has only the 4 keyword for looping. You can do the classic I equals 0 blah 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 loop. Or if you have just a condition, then it's a while. It's an implicit while loop. It's just a bit of syntactic sugar. That's all the easy stuff. If is basically exactly what you would expect, except you don't put parentheses around the condition. It's just a syntactic choice, otherwise it works exactly. Is any other if statement? Blah blah blah. We've already seen most of the basic types. Pool string, a lot of numbers and stuff. Yeah.
So what's the size of int? Is that the best size for the machine?
Int is always 32 to make it a bit more.
Okay.
Make it a bit more more predictable.
Okay.
It's just a syntactic sugar to have int. Easy structs we've already seen in practice. It's not terribly interesting anymore. Go has pointers. C style. So if I say var A is of type vertex, that's not the same than this. A has the type vertex and B has the type pointer to vertex. However, Go makes it a bit more convenient to use to work with pointers than in C. For example, I can do this. A.x. Vertex has the x field. But I can also do this. If the language was more, strict, I would have to do this. The reference B first to get the vertex, and then access its field. But this is transparent. You don't always need to type it. Interesting. And there is no pointer arithmetic. Yeah.
You have references to references.
Yeah.
And they're automatically.
I'm not sure.
var C star vertex.
Yeah. I'm not sure actually if it works. You can try it out. But this is something you almost never see.
Okay.
I've never seen it.
Okay. Yeah.
I never really saw an
I'm being
application.
facetious, I know.
And even in the standard library, you don't really see it. But okay, let's make
Star C.
my vertex is it's a new vertex 1, 2, and we can already reference it. So my V is now a pointer to vertex. And now, if I say this is again the address of my V. So now, basically, indirect is of type vertex. Let's try out.
Yeah.
This works. It will tell me that these variables are unused. That's a compiler error to keep code clean and go. It seems to do it only one.
So if you put star indirect directs now.
Here we go.
Okay.
So it does one level. But like I say, if you read through the standard library code, you basically you never see this. Maybe one more word about pointer arithmetic for people who want to write really low-level efficient code. Like I said, it's not built in Go. So for example, this is not, you can do this in C, right, with the pointer, but this is not valid in Go. However, if you really need to do this, you can do one thing, you can say import unsafe, and this gives you an explicit type called pointer. And pointer is just an alias for int, and then you can do your stuff if you really want this. But they did it like this to discourage it a little bit. It shouldn't be what you normally do. Blah, blah, blah. Yeah, we have maps.
Is Go designed to work on traditional CPUs, or is it designed also to run on virtual machines like the JVM or?
So far there is only, there are two compilers so far for Go, but they are both compilers. So they actually compile right to machine code.
Right.
The only, maybe, it has a little slice of virtual machine in it, namely for the Go routines that we saw before. The compiler compiles a bit of code that does the scheduling of the Go routines into your executable. Other than that, it's straight to machine.
Okay.
Theoretically, you could certainly write a virtual machine for it. There has been no issues so far because the people coming to Go tend to be the kind of people who are looking for something that's a bit closer to the machine. And so there is the official Go compiler from the Go team, and there's also a backend for GCC. It's called GCC Go, and the code it creates is a bit faster because GCC has already 20 years worth of optimizations built into it. But the Go team said that now that Go 1 was released earlier this year, the language will not change anymore for a couple of years. The library can, but not the language. And now their efforts are mainly focused on performance. And it will become a lot faster. It has already become a lot faster. I mean, even Go 1 is certainly a lot faster than Python or Ruby or something like that. And now it's again about 40% faster than most benchmarks. It's pretty good. Slices are just Go lingo for what is basically a normal list or array type in Python or Ruby. It's like an array of variable size. But Go also has fixed size arrays. Again, if you want to write very efficient code, you can say this will never grow, and then it goes on the stack. If you need that. Okay. This is your closure question. Functions are full closures, and they are also full values. You can pass them into a function, you can return them from a function. But you've seen this in other languages, it's not terribly interesting. Switch statement, it's a switch statement. The difference from C is that it does not automatically fall through. You don't have to say break. So, this tour of Go is made so that after, it has basically three parts, and after each one, we're now through the first one, which is basic syntax, and after each one there's a couple of small exercises. Now, I think it would be cool if you try to work on those, because it's a much better way to learn than just listening to some guy sitting there. Although some of you don't have a laptop with you, so I'm not sure if it's worth proceeding that way. Maybe one thing we could do is I could try to implement this here, so you see if I actually know what I'm talking about, and you could kind of follow along with me. Maybe that would be a more reasonable approach. This is basically, this will just recap, just be a recap of what we heard in the last few minutes. Actually, it's also lunchtime, basically.
let me, to finalize, I mean maps and stuff and for loops is not terribly interesting. Let me go a bit further to where we use the Go routines, because this is really the interesting part of Go. And then we can wrap it up there. Blah, blah, blah. Okay, this is worth taking a few seconds to show. Go has a built-in HTTP package which is amazingly easy to use and pretty fast. Say import net HTTP, and then you say HTTP listen and serve where, and you give it a function. You know, function are first class values. You give it a function that takes a response writer and a request, and there you have your first web server. So this is a full web app with a server built in. And this is not a toy actually. We use Go at work, and we just recently launched a beta of a new web page, and it uses completely this built-in net HTTP. No Apache, no Nginx. This HTTP package uses the Go routines behind the scenes, so every request that comes in launches a new Go routine, so it doesn't block, and it works just fine. So if you actually had a little, you know, you have a CSV file lying around and you want to write a REST interface for it that returns JSON, I think you can do it in 50 lines. The whole thing, like reading the file, starting a web server, and printing JSON. In that sense, it's for a statically typed language. It's amazingly easy to use.
Sorry, question on function. I think you're on the way. Does it have keyword arguments or arguments positional only?
No, unfortunately not. Concurrency. Yeah. They say it more concisely than I did before. Go routine is a lightweight thread managed by the Go runtime. So Go blah 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 simply executes the code, but asynchronously. That's it.
So can you go back to that previous example? So the runtime.coshed?
Yeah, this is something you don't usually need. They put it in here to keep the example more concise. This is there are limited ways to interact with the Go routine scheduler. Here you say let someone else run.
Okay. Is it guaranteed that someone else will run, or is it not determined?
If there is someone that can.
Okay. So that should say world, hello, world, 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 world. Oh.
Hello world. Hello. So let's see what it does. We do this, and then so this is probably not a deterministic, right? Because we simply we get here first. We say hello. Now we are here. First iteration in this Go routine. First iteration. But we say no, let someone else run, and there is only one other Go routine, which is the main Go routine.
So what is hello again? Oh, sorry, I understand. Sorry. Yeah, I see.
I don't. Why does hello get printed more than once?
Because they call say hello, and this function say will print out hello 5 times.
Say is the same, you know.
It's reusing say.
Say is not a built-in. It's this function
Yeah.
up here.
So
So basically, we're calling say 10 times, 5 times from main, and 5 times from the other Go routine
it's been called once from main.
that we launch here.
Yeah. Yeah. Okay. Yeah.
No, I mean, of course we don't call say 10 times, we call it twice, but each say prints 5 times. So, yeah. First call, second call.
And can you, on that output, add the I to the S, and we see from which iteration
Sure.
comes?
So it should be 0 hello 1 hello.
Right, so it looks like it's doing it in sequence.
Yeah.
I
Which
think
is
the
not-
sequence comes simply from, because we're cheating a bit here. Let's see what happens now. Imported and not used. It's an error.
Okay, so we're getting all our hellos first, and then we're getting the...
So the go routine
Yeah.
is prints the worlds, is never scheduled.
This is an interesting, no, that's not quite true. It would, I mean, as soon as you say, it's an
Yeah.
interesting example, as soon as you say go, it will definitely be scheduled.
But too late.
There's one, we're hitting the special case here that we're inside main, and like in a traditional C Java program, when main is over, the program is over. And
So add a weight
exactly.
2000 or something.
If we would add a weight here, it will work. What's even more elegant is to say that we're done, to synchronize, to let the asynchronous say signal I am done. And the way you could do it is like this. You give it a channel. Let's say of bool, it could be anything.
The channels have to have types.
They have to have a type. Actually, so bool is fine, why not? And then once we're done here, we send to done that we're done. And here in our main code, we make the done channel, it's a channel of bool. We pass it to this. Now if I run this, the same thing should happen then now. Not enough arguments. Okay, now I have to. Here it's a bit pointless. Yeah, I shouldn't. This doesn't make much sense anymore. Go like this. Yeah, no output. I mean, I have a nice channel and so on, but I'm never reading from it. What I want to do here is launch this asynchronously and wait until we're done. Read from that channel. As soon as there is something incoming, I mean, we block here until something comes into the channel, and then we're done.
How would you do it using close done rather than writing a value to it?
With
Okay.
close,
How would you block on a channel being closed?
close is
You do it for
Probably
X
not.
range
yeah.
channel.
Yeah,
thing.
close and range would be useful here if, let's say, if say would not print the values itself, but it would send them over a channel.
You can still, you could have a channel which you send no items and then close it.
It just wouldn't make any difference whether if I send no items on it, whether I close it or not. No one's listening on the channel, so it
Well, at
doesn't.
least you've got a for loop in the main.
I see what you
Yeah.
mean. Yes, yes,
Yeah.
you can definitely do that. For something, my bool coming from done,
Yeah, you just have an empty loop.
exactly,
Yeah,
and then here close done.
yeah.
Yes, this absolutely works. In this case, it would be a bit more cumbersome to do, but it would definitely work. Let's try it. Yeah, the guard not used. Yeah. The Go designers decided, it's a bit controversial, they decided that there are no warnings in Go. There are only errors. Everything doesn't look right is an error. So it keeps your code clean at any time, but it can be a bit annoying.
Underscore?
I'm actually trying to type an underscore. I know.
So, no,
Oh,
just something.
Yeah.
The lunch will be at 1:45.
Okay.
So you can continue until 1:45
Cool.
with your Codelab. And then it would be good if all together we can go on the one all together
Sure.
at the kitchen.
Origin.
Okay, good. Thanks.
Have fun.
Yeah. What was this error? I mean, underscore means I don't care. You know,
Yeah.
But the error is I used the colon equals, which is a declaration syntax, and I cannot declare the underscore because it's already built in. So, yeah,
Okay.
now it works. Program from a design point of view, one thing that would not be great about this solution is that you make your channel at some point, at some place in one coroutine, and you close it in another. That's a bit hard to understand and to read in a larger program. You should typically close it where you make it.
It's a semaphore or something which is which you then block on in main.
Yeah. For example. Yeah. Exactly. Yeah. And now let's maybe to visualize or to understand a bit better what's going on. Let's go back to the old signal done. But what if done is a channel with a buffer of 5? I would expect that we don't see any printout. We do?
Yeah. You're
Why?
still reading one value from it. The 5 is just an upper limit on the maximum pending values at any one time.
Yeah.
That's right, but I thought that that say would yeah, okay, no, we run, it's a timing, probably timing thing.
No, I think you're putting an upper limit on the number of the queue length,
Yeah,
and as you're only trying to read one value, that's fine. You never hit that 5 limit.
because I only write once, of course.
Yeah.
Yeah, sorry, that was my mistake. Yeah, I only write once. If I had, if I would write after every iteration or something like that, then the two routines would really run asynchronously because it doesn't block it doesn't wait on the channel.
If you write the done equals true inside the for loop, and now set the channel length to something less than 5, that should then block in the. Then we should only get a couple of missing bracket lengths. Then we'll probably get 2 or so.
Yeah.
And now the say go routine is blocking because the channel is full.
Yeah.
And then main terminates, so the rest of the say
Exactly,
go routine
main.
runs.
Exactly. In main, I said I'm only interested in a single value.
Yeah.
So as soon as I get the first one, main is over.
Yeah.
Of course, you can just as well do a counter over channels. You can put a variable here. Counter is. Why is it an override? You could just as well assign variables, or you could do, if this was a channel of int, you can say read from it and decrease the counter or something. I hope we get to the select statement, which is another built-in, which shows a lot of power. Select statement is, imagine a switch, it's like switch, but the cases are operations with channels, and the channel where it gets a value first, that thing will be done. Here we have a method that sends, we give it 2 channels. One for the actual values that the function generates, and one for signaling it to stop. So this is an endless loop, for without condition. So this function will just generate the Fibonacci series on and on and on and on. And each new x of the Fibonacci series, it sends to the C channel. So a client that reads from C will get the Fibonacci series, 0, 0, 1, 2, and so on. And at some point we have enough, otherwise this will run forever or until memory is exhausted. And we have enough, and we send okay, stop now. So this client, for example, this client wants the first 10 numbers of the Fibonacci series. So we loop until 10, reading from the Fibonacci channel. Okay, are you with me? We loop until 10, and 10 times we read from this channel, so we got the first 2 numbers of the Fibonacci series. And then we say, okay, we have enough. Stop it. And here, if we read from quit, we return. And without the select statement, this would be kind of tricky to do, because at which point you would probably have to do a complicated if-else. If read from quit, then do this, otherwise do this. But then of course you have a time, you need to have a timeout, because if I don't get anything from quit within 100 milliseconds, then I make the next number, and it would be pretty difficult to program. But instead select is like switch.
Is there a function that tells you if there's data available on channel 3? Can you
No, you have to read it.
okay.
There's a function where you can, I mean, you have a way to check if a channel is closed.
Okay.
But if it's a buffered channel, you can read its capacity, but whether there's something in it, you gotta read. So yeah, here we just look at each of the channels, which one has a value, and then we do the operation. If there is a value on both, it's chosen pseudo randomly. You cannot rely on in case none of the channels has a value on it being sent to it blocks. The select will block, except, like switch, it has a default case. If none of these channels has an incoming value, then do this. So you have the choice whether you want your select to be blocking or not. So these are the first 10 numbers of the Fibonacci series.
Can you just put in a line after the format.print then?
Yeah.
No, sorry, the lower one.
Yeah.
Just if I equals 5, quit, saying 0 to quit. How do you pronounce?
Sure. In fact, the int that we send here doesn't matter, because it's never actually, we don't care what we send. So it's 42. First byte. Because
It's only not,
we told it to stop.
but this is the point that there's still going to be stuff in the C channel. So in theory, this should be able to print anywhere between 5 and 10 Fibonacci numbers, and it should be random.
I think what happens here is
At this point, this means that the select, once i's got to 5 in the main loop, select, there will be data available on both channels.
but the thing is, we return here.
Yeah, but there's still, but we could equally not return. We could,
Yeah,
if the select randomly chooses to read from C, then we'll return another.
You can do any
Yeah.
number of things.
Yeah.
There's an amazing amount of flexibility here, because these channels are first-class values that you can pass around. So, I mean, they're just variables like int or something. So you can, there's actually, there's very interesting documentation about basically patterns of concurrency, of concurrent code. For example, if you want to, let's say you have a typical server-client architecture where a server sends out notifications when something happens, and you want clients to be able to register for the notification at runtime. So you can basically, what you simply do is, in the server, you have an array of channels. These are all the registered clients. If you have a client that wants to register, you make a new channel, and you pass it to the register method. The server will put it into the client's array, and when something happens, it will just loop over all these channels and send out a notification. For example, you can do a lot of stuff. It's really quite interesting.
Is that array of channels protected by some sort of mutex? Does it have to be?
By default, no, but it doesn't have to be.
Okay.
Because it's just there is no. I mean, it's fine to use a channel in different coroutines at basically at the same time, except of course that the order in which the messages come is not guaranteed.
But the data structure of the array of channels is a mutual structure shared between two coroutines then?
No, it wouldn't need to be. I'm thinking of something like.
Okay, so I'm understanding the same.
We have clients, and clients is an array of channels of int, and then we have server has a method. This is a method defined on type server. Something happened, which gets a number, and then we have to notify our clients. Right? So we loop over. What's the problem with numbers? For all the clients, send the integer to. This is simply by default range over an array returns the index and the value. I don't care about the index, so I care about the index. So for each client, set the thing that happened to it. And now I need another method. Let's say register. We want to register a new client, and the client can simply be represented by a channel of int. Now we see this, unfortunately, somewhat verbose syntax of appending. This has again to do with they want to give you full control over memory allocation. So yeah, why not? Just put one more client into our clients, and then if there is enough space left in the allocated memory, it will be put into the same array, and if not, it will create a new array, and that's why you have to look at the return value.
It's like reallocate or something.
Yeah. So
So in this case, append is a global function?
append is built in.
Append, okay, so for arrays.
Yeah.
So, yeah.
For what's called slices in Go.
So,
An array is always fixed size.
okay.
That's it. And the slices
Yeah.
has an underlying array, but if you append and the array is already full, it will transparently allocate a new bigger one.
Yeah.
So yeah, that's for example how you could write something like that.
And this will work because if you have one Go routine is in the middle of executing something happened and iterating through s.clients, another Go routine register has been called another Go routine, but as we replace the s.clients property rather than modify it in place, the thing that was doing something happened will continue to work on the old list. So
The original iteration will continue.
Yeah.
Of course, if you need specific semantics in your program, like the old iteration must stop. Something that you have to do.
Yeah.
But by default, it will do the straightforward thing. There's really there's a large number of design patterns. I don't like the term design patterns very much, but concurrency patterns in the documentation is really good. For example, if you have two clients that can send at any point in time. But you want to receive always one from A, one from B, and then one from A, one from B. So you can use select statement to order. To order the two. No, in that case you don't even do a select.
Yeah, it's you read from
Read from one, read from the second, and then send whatever you get to another channel, and then you will always receive A, B, A, B, A, B. Select default case. No, we don't need to understand the exact semantics. This is a fun little exercise. Let's see, we have a few minutes left. I think at this point it would be good to first go again a bit through any questions you might have or any thoughts you might have to make this a bit interactive. Anything? So far so good?
I would just mention the presentation from Rob Pike at Google I/O this year. He was talking about all these concurrency patterns and everything, and it was really, really good.
I watched it online. It's a fantastic presentation.
Unfortunately, everybody was requesting the presentation, and he kept saying, "Well, I haven't got the chance to do it, and I'm going to put it online soon." And the last time I checked, it was still not online.
I will.
I've just googled it and it's on YouTube. It seems.
Yeah,
Rob Pike has given a large number of Go presentations, and there's a lot. There's if you are interested a little bit in the kind of in the thoughts and some light theory behind this whole concurrency thing, there is an amazing one called "Concurrency is not Parallelism," where he tries to clear up some misunderstandings between those two terms. He says why, for example, in Go, a Go program with Go routines will still be concurrent, even if you have only one core. Then it will not run in parallel because you have only one core, but the design of the program is still concurrent because you have asynchronously executing parts of your program that communicate over the chain, instead of your whole program being like, do this, do this, do this, do this. And in this talk he explains a bit how parallelism is one advantage of concurrent design, that it enables to run it in parallel. But another advantage is that your program often becomes much nicer, much more readable, because you have really independent parts. Whenever this part has finished a piece of work, it sends the result over the channel, and then it can go on and do the next piece of work. It's a very natural way of modeling some things. The Go compiler itself, for example, compiler first has a scanner that goes over the text and sends the tokens like for and variable name to a lexer, and then the lexer recognizes whole expressions like for loop and so on. These are all independently working Go routines. Whenever the scanner has found a token, it sends it over the token channel and reads the next one. Reads.
So it's parallel compilers.
You can run in parallel, but even if you cannot run in parallel, it's still very easy to read and to understand. Okay, this one reads words. Every time it has a word, it sends it on the word channel. And everyone who wants to know what words are in my program can read from that channel and receive it. It's very easy to do.
Are there patterns for channels where you have multiple receivers, all of which, when a message is written to the channel, all receivers read it?
This is a very good question, and I'm
You can simulate it, of course, the same way as you did with the example with the servers and clients, which was a sort of multiple fan out.
I'm at this point not sure. I have never kind of needed to do this myself, but
Don't worry, it's
I would be interested to try it out. Maybe later, if we have a few minutes. I just recently at work I wrote a program that downloads data from Wikipedia via the Wikipedia API. Where you can request articles or just abstract and stuff like that. Then I had to strip the markup and then store the page somewhere. And I had 3 concurrent Go routines. One that downloads over HTTP, and whenever the response is there, it checks is it a 200 OK, and then it sends the body of the response on a channel. And the strip the markup code reads from a channel every time a new page comes in, strips the markup and sends it on. So you can, if your program has any kind of processing pipeline, it's extremely easy to model. Write each piece independent, and whenever it has done something, send it on a channel. Pretty cool.
So, looking at these examples,
Yeah.
how have they done them? Is a web page. I mean, it says waiting for server.
Yeah, there's they simply have a server somewhere that receives this as text, compiles, runs.
So they will actually compile it on their server,
Yeah.
and then run the compiled executable, and pipes the output and send it back to that level 3.
That's right. Or if it doesn't compile, send back the compiler on. And this whole thing is in the normal Go repository. You can check it out and run it locally if you want. Just recently, they've also come out with a tool to give presentations about Go, basically, or about anything with Go code. Where you have your slides and Go code in them, and you can click execute. And then this Go code from the slide will run.
That's the one they were using in Google I/O.
Yeah. Let me quickly see the table of contents. Is there anything particularly interesting? Yeah, we're basically at the end of the intro. Maybe a very quick tour of the Golang webpage. No. Okay. This is probably, for me personally, the best documented language I've used, because you have just one web page. Actually, when you clone the Go repository, you can just download the binary, but if you clone the repository, you don't just get Go, you get this whole web page in the repository. And if you're on the train, airplane or whatever, you have it all right there. Front page has a lot of documents that are introductory, tour, app engine, stuff like that. The Go blog has a lot of really interesting content. And then you have references to usual language specification if you really need to be very sure what happens in memory if you do something. And then packages is simply your package documentation, the standard library. And this is really, the whole documentation tools are also quite nicely done. You see I'm running this on localhost. It's very fast. It's just, it comes built in with this HTTP mode. And if I here I run Go doc. I run Go doc HTTP and it works. And if I have my own Go code somewhere, projects I'm working on, I export the Go path to point to where I have one. Run Go doc. If I read out this page, first of all, it looks crappy, which is my fault because I put my own code at a weird location. But here are all the third-party libraries that I installed from GitHub, and here's my own code. It's all integrated in one documentation page. Quite nice. Yeah. What I put on here is just, there's a large amount of resources, but just the basics is I mean, here it's basically, no, the other one. I double click here and highlights the other. Anyway, the golang.org/doc is basically yeah, you can spend a couple of days there. It has links to the blogs, to video presentation, to everything. This is an independent webpage which is pretty nicely done. It has a ton of examples. How do I print JSON? How do I whatever? Read from the channel but time out after 3 seconds, stuff like that. And this is a fantastic article by Rob Pike from the Core Go team. Explains a lot of thoughts why Go is the way it is. If you're interested in why did they do it that way, especially when you're annoyed with something in the language. You know, this is a cool article. Maybe one thing that's cool, you know that, oh, it's not very easy to read at all. In compiled languages, like C or also Java, which compiles some bytecode, you usually need some build tool, you know, make and Ant and Maven and dependency management, and it can be pretty messy. And I think it's very nicely done in Go too. It comes built in with a tool that is called Go, like the language. And the Go tool basically can do for you whatever you want to build. It can let you read the doc of source code. It can format source code. It's like, you know, it will pre-print it, indent it correctly, and so on and so forth. It will download third-party packages from GitHub or Google Code or wherever, and will install them, and it will run your programs. If it's not compiled, it will compile it to /tmp out of the way, just run it. If you use Go run, it feels very much like in an interpreted language, because you kind of forget about compiling, you just say Go run, that's it. And it will also run your unit tests, say Go test package. I have, what code do I have there? These are just some things I'm playing around with a little bit. But anyway, I'm writing this package called CSP. I don't think it's runnable because it doesn't have a main method, but I can just test it. Yeah. Give the full package name, which is prefixed with its source, with its origin. So Go test, and then it doesn't build right now, but very easy to say Go run, Go build, Go test. All right. Lunchtime. I hope you had a bit of first impression of the language. Yeah, just try it out. It's pretty easy. You can play around first online with this Go tour. You can installing it. It's pretty easy too. Okay. Thanks for coming.